Hello, everybody. Well, today we're going to talk about my favorite subject, and that is digital communication. So let's get into it. All right. So over here is we have a transmitter receiver, and since we got one of these modern devices here, I'm having trouble drawing this morning. It's a transceiver. All right, and the transceiver is connected to a device called a TNC, or terminal node controller. And the terminal node controller hooks to a computer. All right, now the signal comes in on the antenna, all right, into the radio, into the receiver, and it puts out tones here. And the and the function of this device, the terminal node controller, is to convert these tones into data. All right, remember our computer is incredibly dumb, and it can only understand ones and zeros. All right. So the TNC goes between the transceiver, the transmitter receiver, and the computer. Now, in modern times, this device is replaced by the sound card, which is in the computer. So these things are going out of favor, but this is asked on your test. And so now, let's talk about data. Remember, we say data is ones and zeros, right? And this is some typical representative data. Now, the smallest piece of data we can transmit is 1 digit or 1 byte. All right? So the smallest thing we can send is 1 byte. Now, let me just kind of diverge just a little bit. If we we want to send this, notice this is 8 bits. If we think about 8 bits, we also, when we do 8 together, we call that a byte. So 8 bits equals a byte, which is kind of easy. Is also is that if we were to send just 4 bits, that's called a nibble. How about that, a nibble? All right, now let's talk a little bit about data. Let's say we wanted to send 1, 0, 1, 1. We wanted to send that, all right? But when it got over here, we got this, 1, 0, 1, 0. We received that. Notice that this last bit here is incorrect. We sent a 1, but we interpreted it as a 0. Right? Now, how might we devise a scheme so that we kind of know whether we got something that's right or wrong? Well, we do that by sending what we call an extra piece of information. All right? And that extra, so we're going to actually add something. We wanted to, I'm going to change it up. We sent a 1, 0, 1, 1. That's what we sent. All right? Now, if we can tell the receiver something about the nature of the data we're sending by adding an extra bit over here, in other words, we're sending the data. This is the information we want, but we're going to send another little piece of data that kind of indicates some nature of this data. This bit we send, we call a parity bit. All right? So let's say we're going to add all this up, and this adds to 3, and we say 3 is odd. All right? So if it's odd, we're going to send a 0. All right. Now let's assume over here that when we got it, we got this. 1, 0, 1, 0, 0. Remember, this is telling us something about the data we're sending. All right, we add all this up, and oh, it's even. But this thing is telling us it should be odd. So this tells us that this is an error. All right, so this is called even bit parity. All right, so that we are telling the receiver through this bit whether it should be even or odd, and if this doesn't agree, we say, oh, there's an error. All right, now this is a pretty weak error detection scheme, but this is a concept that's introduced and asked on their test. What is a parity bit? That's a piece. That's one extra bit that tells us how to predict whether we receive what we received or not is correct. All right. I want to introduce a few more concepts to you. Is that we want to group our data together, and we're going to group it in such a way that the first piece of thing we're going to send is we call the header. All right, and that's simply the address. All right, and then the next thing we're going to send is our data. All right, and then the next thing we're going to send is the error check information. All right, now all this group of data, we give this a name. And this is called a packet. All right. So inside inside a packet, we have the address of the header, we have the data, and we have a error check. Right now, one of the very robust error checking schemes is called a checksum. And we can make this so sophisticated that we can guarantee that we can predict 100% the errors in the data, the checksum. How this works is beyond the scope of this course. Right? In some packets, we also send what we call an ARQ. So if this thing detects an error, it says automatically request a repeat. Right? So in a packet, there's headers, there's data, there's error checking, and sometimes ARQ is send it again. All right. So let's kind of review. All right. That when in data communications we have a transceiver or transmitter receiver, it produces tones. It goes into a device called a TNC, a terminal node controller, or a sound card, and this comes to a computer. All right. Now, when we're talking about data, the smallest piece of data we can send is a byte. Right? Now, if we want to describe how many errors are in this thing, let's see, we didn't talk about bit error rates. So let's talk about bit error rates. Fouled up here. All right. So if we want to talk about whether it has errors or not, we're going to introduce a term to you called bit error rate. Okay. Now, using this example over here is that if we were to send 4 bits and this last bit was incorrect, we would say the bit error rate is equally 1 bit and 4 cent, or 0.25. So this is a term BER, or bit error rate, and that will be asked on your test. Now let's go through the review. When we send data, the smallest piece we can send is a byte. If we want to count errors, we define the term called bit error rate. We just count the errors divided by the number of bits sent. Okay, that's the bit error rate. All right, if we want to send some error checking information, we want to sort of help us know if we receive something right, we send an extra piece of information called a bit or a parity bit. And if we have, and one way to do that is to add them up. If it's odd, we send a 0. If it's even, we send a 1. That's called a parity bit check. Okay. Now, if we group data together, we string some data together, we tend to call that a packet. We will call that a packet. Inside a packet is a header, the data, the error check. One of the error check schemes is a checksum. This is asked on the test. All right. And sometimes we put an ARQ, automatic request, repeat request, right, called an ARQ. All right, guys, that's it for today. See you next video.